So hello everybody and welcome to What Do Scientists Do? My name is Jessica and I'm joined by our very special guest today. Could you introduce yourself, give us your name and your pronouns?
Hi everyone, my name is Suchinta Arif and my pronouns are she, her.
And what do you study, Suchinta?
So I am a coral reef ecologist, so I study coral reefs.
So I feel like lots of us have seen coral reefs in movies and documentaries and stuff, but what is a coral reef exactly?
That's a great question. So coral reefs are ecosystems that are underwater and they're characterized by reef-building corals. So these reef-building corals are actually made up of coral polyps, which are these tiny 1-inch animals related to jellyfish and sea anemones. And they live in large colonies of hundreds and are held together by calcium carbonate. And once they die off, the calcium carbonate remains. So over time, they build up into these larger coral reef structures. So these tiny 1-inch animals are responsible for some of the largest coral reefs in the world. So the largest one we know of is actually in the Great Barrier Reef, which spans about 1,600 miles. And it's so large that it can actually be seen from space.
That's so cool. I'm curious, have you ever gotten to visit the Great Barrier Reef?
I haven't, but it's definitely on my to-do list.
Yeah, that'd be pretty cool. I remember I was super into the Great Barrier Reef as a kid. So you mentioned that coral reefs are like these big structures made up of all these tiny things that have calcium carbonate. Calcium carbonate, what is that? Does anything else in the ocean have it?
So calcium carbonate, it's kind of like limestone, and lots of creatures use it to make their shells. So for example, anything with a shell often has calcium carbonate in it.
Super cool. Okay, yeah, so it's that like hard stuff that you see in shells, and little coral polyps also have it. Do you have a favorite thing about coral reefs?
So my favorite thing is how biodiverse it is. So when something is biodiverse, it means there are lots of different species living there at the same time. So coral reefs are actually one of the most diverse ecosystems in the world. And for that reason, people often refer to it as rainforests of the sea. So about a quarter of all ocean species depend on coral reefs at one point or another, even though coral reefs make up less than 1% of the Earth's total surface. So they're home to a range of animals, including fish, sea turtles, birds, as well as marine mammals and plants.
Yeah, so I'm picturing them kind of like the cities of the ocean. Like all these different species all living together, even though some of them live farther away from the coral reef and maybe they come there to feed and stuff like that.
Exactly. So some will live on the coral reefs the entire time, whereas others may spend a short amount of their time there. So when they're younger, they might use coral reefs as shelter, and then when they're adults, they don't live there. And others will come in and out. So there's a huge diversity of animals that use them for shelter, for food, and at different levels.
That's super cool. They're like a really important ocean hub. What do coral reefs do for us? How do they help us as humans?
So this is a really great question. So coral reefs offer many ecosystem services. And what that is essentially services that we get from ecosystems. So an estimated 1 billion people actually depend on coral reef for these ecosystem services. So these include fisheries. So as I said, there are lots of fish that live in coral reefs. So a lot of local communities as well as people abroad depend on coral reefs for their food, and local communities also depend on fisheries for their income. Coral reefs also provide shoreline protection. So they create a natural barrier between the ocean and land. So they can provide erosion control, they can limit flooding, they can limit the negative impacts from storms and storm surges. And of course, they also help us through tourism as well as recreation. So if any of you have ever been snorkeling on a coral reef, you know how much fun that is and how meaningful that experience is.
So it sounds like they're pretty important. Is there anything that might be threatening them?
Yeah, they're actually a pretty vulnerable ecosystem right now. One of the things that's impacting them is climate change. So when you have increasing temperatures, this can actually lead to something known as coral bleaching. So what this is corals they actually live with an algae known as zooanthellae. And they live within their tissues and they provide the coral with food, oxygen, as well as removing waste, whereas the coral provides them with the compounds needed for photosynthesis as well as shelter. So, because both of these organisms are benefiting from their relationship, this is known as a mutualistic relationship. And when you have severe heating events, often the algae, the zooanthellae, will leave the coral, and this will turn the coral white, and this is known as coral bleaching. And when this happens, the coral becomes more vulnerable to dying off, and it's often very hard to recover back into a healthy coral state.
Yeah, so that sounds like it's not a great situation for the coral reefs then. Is there anything that we can do to help?
So, one of the main things we can do collectively is to be conscientious about how we tackle the current climate crisis. So, try to limit our waste and our carbon footprint, as well as vote for those who are in power, who are making policy decisions to try to shift our society into a more sustainable way of living.
That sounds all super important. A lot of that stuff is maybe things that it feels like you can't do until you're an adult. And it's true that you can't vote until you're an adult. But is there anything that you could do as a kid to help?
So, one of the things you can do is when you're buying seafood, for example, just to make sure that they have been caught sustainably, because overfishing is also another threat to coral reef ecosystems, as well as destructive fishing practices.
That sounds manageable to me. So you talked about all this stuff with coral reefs. How do you go and study them?
So, one of the main ways we understand what's happening with coral reefs and how they're being impacted by these different threats is to actually go underwater and survey them. So, there are various different survey methods that are available. I'll describe one very briefly, and this is known as a transect survey. So, these are kind of fun. So, what you do is you dive underwater to a coral reef site and you put down a transect line, which you can think of as a measuring tape. And then a researcher who's diving will swim across this transect line and they'll look to the left of them and they'll look to the right of them and they'll note down in their underwater pencil and paper all the different species that they see. And they'll also collect information such as the size of different fish species that they see, as well as environmental variables such as the temperature of the water that day, how deep the coral reef site is, and so on. And this is often standardized so that the data can be trusted.
Cool. So in order to be someone who researches coral reefs, you have to learn how to scuba dive, right?
Not necessarily. So there are a lot of different kinds of coral reef scientists. Some of them are very good at scuba diving and collecting that data, whereas others, like myself, depend on that data and then focus more on the analysis aspect. So now that we have all of this data, how do we answer these questions that we have through statistics and analysis?
Cool. And what are some questions that, or some things that you've been able to explore with data from these coral reefs?
So, one of my main projects that I've had the privilege to work on was data that was collected for a long time on coral reefs in Seychelles. So, researchers, not myself, collected data across 21 reefs from 1994 to current day. And they collected all of the important data, such as how much coral reefs there were at a site, what species were there, how deep these corals were, and so on. And in 1998, there was a climate induced bleaching event that led to about half of these coral reefs turning into macroalgae systems. So after the bleaching happened, the corals died off, and in its place, there were macroalgae instead. So the entire ecosystem shifted, and this is known as a regime shift. But what's interesting is that the other half of the coral reef sites recovered back to a healthy state. So because we had all of this long-term data, we wanted to answer the question, well, why were half of these recovering and the other half didn't? And with this data, I was able to find out a few different things. So what we found was coral reefs that were deeper were actually more likely to recover. And that's because when you have a heating event, deeper coral reefs are more protected. Also, coral reefs that were more structurally complex, so there were more reef structures, were actually better protected as well and were more likely to recover. And that's because they provided more shelter and more habitat for a diverse amount of fishes, which actually ate the macroalgae, preventing them from taking over later. And another interesting thing we found was that coral reefs that were dominated by branching coral, which are these very pretty corals but are fragile to bleaching events, were, of course, more likely to turn into algae-dominated systems.
Cool. So it kind of gives you an idea of which kinds of coral reefs might be more vulnerable, right? So that you can keep an eye out. Is that the main thing that you would use this for?
Exactly. So this can help us answer questions about where should we strategically place marine protected areas. So of course, marine protected areas are sites where you limit the amount of fishing and destructive human practices. So you try to allow the ecosystems to recover and stabilize and thrive. So what this study is showing is that if you're creating a marine protected area for coral reefs, you might want to prioritize reefs that are deeper, that are structurally more complex, and that have more resilient coral species growing in them.
That makes complete sense. That sounds like it's super useful data. It's wild was that 35 years worth of data? Or was it just from the 1994 to 98?
No, it was 1994, and we're still collecting data today. So there was actually a second bleaching event that occurred in 2016, and we're currently trying to answer more questions with that as well. So it's still ongoing.
Well, I look forward to seeing what you find out from all that data because it sounds like it can be super useful. Do you have any cool future projects that you're working on?
Yeah, so we actually have a global data set that, believe it or not, was collected mostly by citizen scientists, so not necessarily researchers themselves. And I'm trying to look at how different variables, so different factors such as how deep corals are or how close they are to human society, might be impacting the ecosystem services that we get from them across the world.
That's super cool. I love citizen science. Do you have, in general, we've talked a lot about coral reefs. I know you've done more than just study coral reefs. Do you have a favorite science thing that you've ever done?
So my favorite science thing is actually what got me into the marine ecosystem world. And it was when I was an undergraduate student at the University of Toronto, I decided to take a few field courses at Banfield Marine Science Centre, which is all the way in British Columbia. And it was really my first time being immersed in the ocean and learning from marine scientists as well as enthusiastic marine ecology peers. And it was a delightful time. And really, it's what made it click for me. I was like, okay, I'm going into marine science.
That's super cool. Is that the one that's on Vancouver Island?
Yes, it is. And it's very remote. So you really get a very unique, immersive experience. I highly recommend it.
Yeah, that sounds amazing. I'm sure it's beautiful there as well. Thank you so much for joining me today, Suchinta. Do you have anything cool that you're working on that you would like to promote?
I do. So, because the thing that got me into science were these kind of co-curricular immersive experiences, I actually, with my colleagues, started my own scientific outreach organization. We're known as Diversity of Nature. So we provide free and immersive outdoor experiences geared towards Black, Indigenous, and people of color youth across Nova Scotia. And we have a lot of fun activities coming up this year, including a Halifax Shark Week that you should look out for that will be out sometime this summer.
That sounds like so much fun. Halifax Shark Week, amazing. Just no explanation needed. Sounds like a fun time. So yes, if you're interested in more of the work that Diversity of Nature does, you should definitely check it out. I will definitely put your website and everything up along with this podcast so that you can see what they're up to. They do lots of very cool things in the Halifax area and Atlantic Canada.
And as always, a big thank you to everybody listening. For more science fun, you can check out @ScientistDoPod on Twitter or Instagram, or you can find our past episodes at bit.ly/whatdoscientistsdo. To learn more about diversity of nature, you can check them out on Twitter at diversityofnat, that's diversity of NAT, or at diversityofnatureNS on Instagram. You can also check out their website, diversityofnature.com. Thank you so much for listening, and I'll see you next episode. Bye for now. This podcast was made by Supernova at Dalhousie University, a network member of Actua. For more information on our summer camps, workshops, and more, check out supernova.dal.ca.